Many of you have expressed difficulty with the binomial distribution, which is part of Module 2. So I wanted to kind of review quickly what is a binomial distribution and then look at how to work some examples or problems with the binomial distribution. So a binomial experiment, which ultimately leads us to a binomial distribution, is a probability experiment that satisfies the following four requirements. Okay, so first of all, if you're going to conduct a binomial experiment, there must be a fixed number of trials, meaning you got to know how many times you're going to do the thing. So if you're going to flip a coin, you have to tell me you're going to flip the coin 10 times or 20 times. Each trial can have only two outcomes or can be reduced to two outcomes. So again, thinking about the example of flipping a coin, there are two outcomes because you can either flip a head, which is one outcome, or a tail, which is the second outcome. Now, the idea of it can be reduced to two outcomes is think about rolling a die, which is a six-sided cube. And maybe your desire is to roll the number 5. So you could say 5 is your success because you would get what you want, but then your failure would be not 5. And there are multiple options there because you could roll a 1, a 2, a 3, a 4, or a 6. And that would be considered a failure. So a success is you get what you want. We represent that by the lowercase p. Failure is you do not get what you want, and it's represented by the letter Q. Third, the outcomes of each trial must be independent of each other. Basically, what happens the first time you flip the coin does not affect what happens the second time or the third time or the fourth time. Even in rolling the die, the outcome that you get for the first roll does not affect what happens for the second roll, third roll, fourth roll. And then finally, the probability of success must remain the same for each trial. You basically got to flip the same coin every time or roll the same die every time. You don't change things up. So the other thing that I would tell you is this table here, which is scrolled over 2 pages here, needs to become your friend. I would strongly encourage you to make it smaller and put it on your note sheet for the midterm so that you have it. I cannot even do these problems without referring to this particular table because it helps me to know what pieces of information I should read or calculate within MINITAB. So this particular table needs to become your friend. Okay, so let's move on to some examples. And the first example I have here says the probability that a student uses the Academic Resource Center on a regular basis is 0.33. In a group of 19 students, what is the probability that exactly 7 of them use the academic resource on a regular basis? So before you can even begin working this problem, you need to identify some information. You need to know the total number in your sample. How many times are you performing this particular experiment? Okay, in this case, it is 19 because it tells us in a group of 19 students. You also need the probability of success. A probability of success here is that they use the academic center. And it very clearly tells us that the probability that they use the academic center is 0.33. And then it says you need to know X, which is how many successes do you want. And in this case, it says, what is the probability that exactly 7? So I'm interested in 7. And the key word there that I have to focus on is exactly. Now, I went ahead and copied from the table above. Okay, so if I go back up here to my table and I look for that keyword exactly, it tells me what to do in MINITAB. It says read results directly from MINITAB for the X value. Okay, so I copied that here onto right below the problem, so you'll know exactly which one goes with this problem. So then I'm going out to MINITAB, and the first thing I have to do is enter the number of possible students. I have to enter all of the possible values for the X, and that can be any number of students from 0 all the way up to 19. And I went ahead and I've entered from 0 excuse me, to 19 into the computer. And then I need to perform my calculations. I've got to calculate my probability distribution. So I'm going to go to Calc, Probability Distributions, and we're doing a binomial. We're doing straight on probability, not cumulative. I have to tell it the number of trials. How many times are you performing the experiment? We're doing it 19 times because there were 19 students. The probability that they use the Academic Resource Center was given to us. The event probability is your P. And then we need to tell it our input column. Where are your numbers? They're in column 1. And then where do we want to put the answers? And I usually use C2 for my answers. So I tell it, okay. And MINITAB calculates the probability of each event for the probability that they use the Success Center. Now this one said exactly 7. Okay, so, and I'm told to read the instructions or to read the value for 7 directly from MINITAB. So I'm going to read this number here. In fact, I'm just going to copy it and paste it onto my document. Okay, so my answer is 0.175720. Now you can use the full decimal value. If you're asked to round, you should round appropriately. But this would be the answer from MINITAB for this particular question. All right, moving on to the next one. It says, the probability that a randomly selected individual in a certain community has made an online purchase is 0.44. Suppose that a sample of 13 people from the community is selected. What is the probability that at most 3 of them has made an online purchase? Okay, so again, the first thing that I need to do is to identify my N, which is the number of times I'm going to perform the experiment. And in this case, it tells us that 13 people are being selected. We need the probability of a success. The probability of a success here is that they've made an online purchase, and that probability is stated as 0.44. And then we need what are we looking for? And it says, what is the probability of at most 3? So my value for X is 3, but we have at most. So the probability, again, I found it in the table. Again, I focus on that word, at most. So the probability of at most X successes, which means X or less. And it tells us we're going to add the results from MINITAB for X equals 0, 1, 2, 3, all the way up to whatever the X value is. So again, I go out to MINITAB, and I haven't set this one up, okay? So I'm going to put this one in column 4. I'm just going to put made online purchase. And we're considering 13 people, but remember it could be 0. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we numbered 0 to 13. And then I'm getting ready to calculate the probability. I'm going to put it in C5. Okay, so we do calc, probability distributions, binomial. Again, we're doing probability. My number of trials is 13. Probability that they made an online purchase is 0.44. My input column this time is C4. Okay, my input column is C4. Doesn't like that. Okay, hold on. And then C5 is where I'm going to put my probability. It does the probability. All right, so I'm going back to see what I'm supposed to do. I'm supposed to add together the results from MINITAB for 0 up to the X value, and my X value is 3. So I need to add together 0, 1, 2, 3. I'm going to copy those answers over into column 6. And then I can use MINITAB to calculate those things for me. I can tell it to do the column statistics, and I want it to add them together. Okay, and they're in column 6. And I can tell it to put the result in column 7. Maybe I don't need to tell it to do it in column 7. Just tell it okay, and it gives me the result. So when I add these 4 numbers together, the 0, 1, 2, 3, I get 0.01. Here's my answer. 105515. So I would transfer that over here. My answer would be 0.105515. Okay. Now, if you need to manually add that together with a calculator, you can do that. But if you want to use those few extra clicks, it kind of does it all for you there in MINITAB. It would really probably make your life a lot easier. Typing it into the calculator, you could possibly make a typing error. Okay, so moving on to the next example, which reads, at a major international airport, 0.44 of the flights arrive on time. A sample of 10 flights is studied. What is the probability that more than 3 of them arrived on time? So here again, we've read through the question. We need to first identify how many times we're doing the experiment. It says we studied 10 flights. My probability of success that the plane arrived on time is 0.44. And then my X value is 3, and my keywords are more than. So again, I go back up to the table, and I look for those keywords, more than, and it tells me, and I've copied it here, that I need to add the results from MINITAB for X plus 1, X plus 2, all the way up to N. Notice in red it says do not include the result for X, because the question says more than that. So you're not including the X value. Okay, so I'm going out to MINITAB again. Okay, this time we're talking about flights. So I'm going to go to column 8. We're looking at 10 flights, so we could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to calculate my probability for those. I'm going to calculate probability distribution, binomial, So I have probability. My number of trials is 10. My event success was 0.44. My input column is column 8. I'm going to store my answers in column 9. And it automatically does all of the calculations for me. Going back to confirm what I should do. Add the results for x plus 1, x plus 2, all the way up to n. So in this case, that means I need to do 4, 5, 6, 7, 8, 9, and 10. So I'm going to start at 4. So I need 4, 5, 6, 7, 8, 9, 10. Right click. I'm going to copy those. Then I'm going to paste them into column 10. I want to calculate the column statistics. I want it to do column 10. And I get an answer of 0.712331. Guys, this is so much easier if you'll use that copy and right click, because it will automatically do the addition and you don't have to worry about retyping them in. Okay, so I'm going to write my answer down, 0.712331. So my answer is 0.712331. All right. This particular scenario goes with the next two questions. Okay, so it says a survey finds that 59% of employed adults believe that if they lost their job, it would be easy to find another one with a similar salary. Suppose a random sample of 8 adults is selected. And then the first question says, what is the probability that 6 of those in the sample believe they could easily find another job? So again, one of the first things we want to do here, guys, is we want to identify our N. Okay, so the N for the next two problems is 8, because we had a random sample of 8. The probability that they believe they could find another job with a similar salary, you got to be careful here, guys, because it's given to you as 59%, but we have to enter that into MINITAB as a decimal. So remember, you have to divide by 100 to convert that percentage to a decimal. And then for the first question in this particular scenario, my thing is 6. Now, it doesn't really use the word exactly, but hopefully you can realize it doesn't say less than, greater than, fewer than. If it wanted to say something like that, it would. So it kind of implies, it says that 6. So it really reads that exactly 6. So again, for doing exactly, we just read that number. Okay, so I'm going back out to MINITAB. This time I'm going to go to column 12. And we're doing adults, and we have 8, so we can do 0, 1, 2, 3, 4, 5, 6, 7, 8. Guys, you got to make sure you include the 8 each time. Okay. Then I'm ready to calculate the probabilities. We have, again, calc, probability distribution, binomial, probability. We have 8 trials. Our probability of success is 59, or 0.59. My input column is column 12. We're going to store them in column 13. You can replace column 1 every time. I'm just trying to show you all of them here at once on this particular page. Okay, so this one was exactly 6. So we're going to read the number next to the word 6, or next to 6. So I have 0.198535. In fact, I can copy that and just put the answer on my page. Now, again, you need to pay attention, because if you're asked to round to, 3 places 4 places, whatever, you need to do that. All right, using this same scenario about the survey of adults, okay, the next question says, what is the probability at least one in the sample believe they could find another job? So we still have, in this scenario, we still have the 8 adults. The probability they believe they could find another job is 59%. But my X for this problem is 1. And I have the key phrase at least. And looking at what I'm supposed to do from the table, again, please make the table your friend. Add the results from MINITAB for X, so that means we're going to include the 1 all the way up to N. So in this case, we would do 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I'm going out to MINITAB. I've already entered 0 to 8, and I've actually already calculated the probabilities. I don't have to recalculate them, guys. Okay, you can if you want to, but you don't need to. So I'm going to copy the values for 1, 2, 3, 4, 5, 6, 7, 8. Right click, copy, paste them in column 14, and then calculate your column statistics. And I'm doing column 14, and it gives me 0.999202. Okay, so the probability of at least 1 would be 0.999202. Okay, so again, I cannot stress enough to you guys, please. And I would strongly encourage you to make sure that you have this table on your note sheet that you are going to be allowed to use for the midterm exam.